Okay, what's going on, guys? It's my Odo Billy here, and today we're going to be working on MathCon, and the reason why is because we're celebrating. We hit our goal of 15 subscribers. Here, I'll even show you. Oh wait, no, I can't. Sorry, guys. Sorry. But right now we are dividing decimals because you gotta solve it. Now, I'm already way ahead of you, so you guys better catch up. Oh yeah, you guys don't know how to do this stuff.
Let's see if we can divide 30.24 divided by 0.42 and try pausing the video and solving it on your own before I work through it. So there's a couple of ways you could think about it. We could just write it as 30.24 divided by 0.42. But what do you do now? Well, the important realization is when you're doing a division problem like this, you will get the same answer as long as you multiply or divide both numbers by the same thing. And to understand that, we could rewrite this division as 30.42 over 0.42. We could write it really as a fraction, and we know that when we have a fraction like this,
whatever. Okay, sorry about that.
We're not changing the value of the fraction if we multiply the numerator and the denominator by the same quantity. And so what could we multiply this denominator by to make it a whole number? Well, we could multiply it by 10 and then another 10. So we could multiply it by 100. So let's do that. If we multiply the denominator by 100, in order to not change the value of this, we also need to multiply the numerator by 100. We're essentially multiplying by...
Great! That's all you gotta learn. Now, I've already gotten a head start, so you better catch up like now. Quick. When the clock strikes 2, 3 and 4, if the band slows down, we'll yell for more. We're gonna rock the clock tonight. We're gonna rock till the bright daylight. We're gonna rock all the way around the clock. Look, guys. 5. Okay, I got the answer. The answer is 590. I am the one.
What are you doing?
See, even Dad's getting into it. But, okay, now you know how to do this stuff. You better. Oh, by the way, if you guys didn't know why I'm doing this, it's because I've got MathCon. So this is probably going to be my whole channel for the next couple of days. But do not worry. Cosmic Prisons is one of the biggest series. So I'm probably going to post one of those today. But I just don't want all the people who ain't in MathCon to be all mad and stuff. Don't worry. This is just to help people who are in MathCon. But I've probably already tricked you. By this time, I've probably tricked you by the title. Yeah. In the box, 2, 3 and 4, in the man goes down, we'll yell for more. We're gonna rock, alright, the clock tonight. We're gonna rock till bright daylight. We're gonna rock all the way around the clock. And the clock strikes 2, 3 and 4, if the band goes down, we'll yell for more. We're gonna rock. Now, hopefully I might not be able to go on my current schedule of, the videos, but I'm trying my hardest to. Now, if I'm flying by through these questions, there's also a reason why. It's because we get 45 minutes to solve a question like these. I need a piece of scratch paper. I totally need it. Now, if you guys didn't know, I'm not using a calculator because in the final paper based thing, you can't use a calculator. But I think I'm kind of confused why they let people use calculators. So someone maybe in the comments who didn't get tricked might be able to tell me why they let kids use calculators in like the upper grades. Is it because kids are too dumb these days? No offense. But if you've been distracted by my talking, well then that worked. It better not work. Because I was actually trying to do that so I could solve the problem first. So I'm so close. I'm so fancy. You're ready now. I'm in the backseat from LA to Tokyo. I'm so fancy. Now, if you guys know, if I start bursting into a random song, that's just me. It's just me. It's not just me. Wait. The answer, my friend, is blowing in the wind. Oh my goodness, Illuminati! Too much Illuminati. Da, 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 da. Great, we finished dividing now.
We know that we can
I
find...
don't need to know how to find area of triangles. Sorry, Sal. Let's search a different subject and word problem. Oh, operations. Prime numbers are gonna be simple. And it looks like 2, 3 word problems. Word problems. I got you where I want you. Now I'm gonna eat you. 2-step preferably, because I want to be challenged. Oh. There we go. There you go. Bad thing, but yeah, I'll figure that stuff out later. Next thing, inequality in comparing numbers. Easy peasy. Place value. Easy peasy. Properties. Exponentials. Easy. Binary operations. I'm gonna go with binary operations this time because, but we're gonna use binary. Let's search up binary. There we go. Binary.
Let's see if we can get some experience converting from a decimal representation to a binary representation. And let's start with a fairly straightforward example with a fairly low number. Let's see if we can convert.
Let's add in binary.
Let's see what it's like to add multi-digit numbers in binary. So let's say I had the number 1, 0, 1, 1, and to that I wanted to add the number 1, 1, 1.
Okay, what number is each of those? I'm just solving, so. This is 7, and this is 11. So the answer is 100.
What is that going to be? And I encourage you to pause this video and try to work through it on your own. So the key here is to just do the standard algorithm when you're adding numbers, but remind yourself you're only restricted to the 0 and 1 digits. So let's do that. So we have 1 plus 1. Well, you might say that's 2, but you can't write a 2 here. We only can write a 0 or 1. And we have to remind ourselves that 2 in decimal is represented as 1, 0 in binary. It's 1, 2, and 0, 1s. So you write the 0, 0, 1s, and 1, 2. You essentially carry the 1. And now you have 1 plus 1 plus 1. Well, that's going to be 3, but you can't write 3. Once again, 3 in decimal is equal to 1, 1 in binary. It's 1, 2 plus 1, 1 is 3. And so you just have to realize that. So 1 plus 1 plus 1 is 3, which in binary is 1, 1. So you write 1 in the 1's place, which is that, and then you carry it. And then we want to add what we're doing in the 4's place. And over here, I have a 1 and a 1, which is going to be 2, which we already know we represent as 1, 0. So you write 0 here, and then you carry the 1. And then once again, 1 and 1 is 2, which is 1, 0 in binary. And we're done. We've just added these numbers. Now, you might be saying, hey, let me make sure that this actually makes sense. And we can verify that this actually makes sense by thinking about what these numbers are. Remember, this is going to be, this number right over here, if we wanted to think of it in decimal, is going to be 1.
Wait. Oh, they're adding. Oh, so 11 plus 7 is 18. Oh my goodness. No. That's
1
that's 18.
plus 2 plus not 4, but plus 8.
That's 18.
Plus 8.
Oh my
So this is
goodness,
11 if we were to write it in decimal. And this right over here is 1 plus 2 plus 4, which is equal to 7 if we were to write it in decimal. And now what's this right over here?
18.
This is equal to 1, 2. And this is 4, 8, 16. So this right over here. So we have 116 plus 1, 2 is going to be equal to, this is equal to 18 if we're writing it in decimal. And we see that 11 plus 7 is indeed equal to 18. 11 plus 7 is indeed equal to 18.
Oh, that's actually pretty smart. Yay, let's start multiplying.
I now want to show you that the standard algorithm for multiplying numbers can also be used. It's not just limited to base 10. It can also be used, frankly, it can be used in any base, but we're going to do it in base 2. And base 2 is especially fun because you essentially have to only know your
Base 2 is 0 and 1.
your multiplication tables through 1. So you just have to know that 0 times 0 is 0, 1 times 0 is 0, and that 1 times 1 is 1. And then you're ready to go. You're ready to multiply in base 2. So let's do that. So let's say we have, let's say we take 9. So let's see, 9 is going to be 1 8, 0 4s, 0 2s, and 1. So this is 9 right over here, represented in base 2. And let's say we were to multiply that times, times 7. So we should obviously, if we know our multiplication tables, we should get 63. So 7 is 1. Actually, I'm going to put a 0 in. 7 would be 1, 1, 1, but that's a little bit boring. So let's instead do 9 times 5, which we know should be 45. So this is 1, 4, no 2s, and 1, 1. So 4 plus 1 is going to be 5. So this is 9.
I think I have a superstition why people choose 7. It's 1, 1, 1.
Times 5, and we're doing it in base 2. So once again, same algorithm. And actually, before I do it, I encourage you to just pause the video and try to use the same algorithm that you've used for base 10.
You know what? Let's try that. Use the same algorithm you use for base 10, more or less. Let's see if it actually can apply. How many of you actually said bless you? 0. I knew it. Then I bet at least 5 of you said bless you. I'm smart. I quit. It worked!
Multiplication. Use the same algorithm here, and let's see if we actually do get that 9 times 5 is 45. So I'm assuming you've had a go at it. Let's work through it together. So let's start right over here in the ones place. So we multiply 1 times 1 is 1. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. Then,
I'm sorry if you guys don't get it, but I get it, so. I'm only doing the 5th grade, so can I split that up into 4s, thirds, or 1? We stopped. You know what, guys? That's going to be it for today, guys. I hope you guys did enjoy learning about math. There are other stuff here, but that's not. Area and volume of 2D and 3D figures. Least common multiple, greatest common factor. And this is 6th grade. I easily know that stuff. Pythagorean theorem. Pretty cool. 12th grade exponential, blah blah blah. Area and volume of 2D. Oh, volume of 2D is probably hard. Okay, area. This is 12th grade. But anyway, guys, we're gonna end it here. Is this sure? No, actually not. So I hope this did help you with math, especially if you're a math con, because this is the math con thing that you should do. Because yeah, some of us are in it, and we might be able to go to Illinois. If we actually go into Illinois, we're gonna be vlogging, yeah, if we do. But see you guys.